So I guess to start with, we're going to talk about operations knowledge fabric, and don't worry, we'll explain what we mean by that and how it's powering scalable AI for the AstraZeneca's bold ambition for 2030. But before we do that, we'll do some quick intros. So Maria.
Yeah, thank you, Russell, and hello everyone. So my name is Maria Sorokina. I am working in AstraZeneca operations IT, and I'm the knowledge graph and the semantics lead. I have a background rather in bioinformatics, biology and biochemistry. Now I'm supporting a different type of business within the pharmaceutical industry. So we are covering supply chain, manufacturing, and drug development. And my role is to ensure that we are building solid data foundations using knowledge graphs and semantics within operations. And so with this, Russell, your turn.
So yeah, hi everyone, I'm Russell Adams. So I'm from Capgemini. I'm part of the insights and data practice focusing on life sciences. And yeah, I've been partnering with AstraZeneca for the last few years, working through their data foundation journey. My background is across different life sciences, different life sciences customers, and predominantly in supply chain and manufacturing. So lovely to speaking to you all.
Thank you, Russell, for the intro. So within AstraZeneca, we do have a bold aspiration to bring something new and refreshing into manufacturing and in supply chain through technology and AI. Because nowadays, we cannot compete against AI, so we have to use AI and to go along with it. And within operations in AstraZeneca specifically, we want to be sure that we are pioneering the use of AI and of newer technologies within this area. And we do have a bold ambition that is by 2030 to ensure the launch of 20 new medicines, so to put them on the market. And with this, to be ranked in the world's top 10 most advanced, innovative, and sustainable supply chains and manufacturing plants. So next slide, please, Russell. And we are aiming to do this through a quite diverse strategy. So first of all, through innovative manufacturing, where we want to ensure that we have the right modalities and the right capabilities, and also that we're employing the right manufacturing technologies, both the hardware, the software, but going through the people and the technologies that we're using. Then we also aim to have an intelligent and self-healing supply chain. So to create an intelligent supply network. So we don't want to talk about supply chains anymore. We want to talk about supply network that is powered by data and that is self-healing and delivering really top decision performance and a great resiliency. And last but not the least, we also want to leverage people and sustainability because we need to care about our planet. We need to care about the climate, nature, and together with this, we need to care about our people. So we need to ensure that we have the right teams working in the best ways, in the most sustainable ways within the right culture. And with this, it also means that we need to ensure that we place the right technologies in the right place. Where those things belong in 2025 and until 2030. So next slide, please, Russell. So with no worries. So with all of this, we do have quite some pillars that we are building on top to build a really solid foundation for this bold ambition of the IT 2030 and AstraZeneca bold ambition 2030. And so those priorities and those pillars revolve around those three major priorities. So technology, value, and people and sustainability. But I would like really to focus today on the pioneering the new technologies, unleashing the value of data and scale AI solutions and other technologies. Because here today we are doing a technology talk rather than showcasing how AstraZeneca is a great company to work for. And So pioneering new technologies, we cannot escape it nowadays. It is something that we either need to go along, either we fall behind. So we do commit to pioneer new technologies, like knowledge graphs, generative AI, and agentic AI. I don't want to talk about quantum technologies because this will be quite far off the goal for today. But overall, we really want to ensure that we are on top of the things while operating in the pharmaceutical industry that is quite constraining. We also are learning on how to scale for real AI solutions and those technologies. So how to bring them to the different aspects of our operations and on different levels. So this goes from things like Copilot to help you answering your emails faster, to a network of agents that helps to take the right decisions in the right moment in the supply chain. And then we also need to keep unleashing the value and the power of the data that we have. And so that means that we need to bring extra context to the data. We need to ensure that we are using every single bit of it in the way that we understand and that is really valuable. And so if you please move to the next slide, we will be discussing now on how AstraZeneca operations is unleashing the power of AI and of innovation using data, using newer technologies in the heavily regulated pharmaceutical industry that we have to evolve in. And so with this, I'm passing to Russell, who is going to walk you through the problem with AI and decisions.
Awesome. So, yeah, as Maria mentioned, in terms of the bold ambition, a lot of the target and the aim is to enable AI to make decisions at scale. And how do you do that in a regulated environment? And I guess call out the problem. A few weeks ago, I decided to see whether I could trust AI to decide what I wear. So I tested it out. I asked Copilot what I should wear tomorrow. And what it did, it looked at what the weather was tomorrow, which you can tell this is a few weeks ago because it said it was 30 degrees. And based on that, said I should wear a shirt, some shorts, and flip-flops, which is great. But what it doesn't know is the context. So what it didn't know, it understood that it needs to understand the context of what the weather was tomorrow, but it doesn't have my context around what's in my schedule. Am I at a wedding tomorrow? On this example, have I got an important meeting that I need to go to? What clothes do I have clean? Who will I be meeting? What will they be wearing? What fits in? So there's so many sort of elements to think about and context that needs to be understood when making a decision. And this is just, I guess, a silly example, but when you're applying this at enterprise scale, it becomes really important in terms of what is the context you're operating within. And I guess it is possible to provide AI context through vector RAG. However, when you're doing it across multiple interconnected decisions that you need to make to enable a self-healing supply chain or autonomous manufacturing process, it suddenly means that you need a massive knowledge base, and that's where having the right structure and ensuring that the context is captured in a consistent way becomes really, really critical. So just to call out, I guess, instead of what clothes should I wear tomorrow, when we're looking at this in the context of self-healing supply chain, autonomous manufacturing, the type of decisions like what production schedule should I be setting, what should be the inventory policies, the workforce schedules, validation protocols, all of these are interconnected, and all of them have enterprise context that we need to be aware of before recommending decisions to be made. So with that, context is everything. And at AstraZeneca, we've been speaking a lot around the pyramid of wisdom. So wisdom being at the top, and this is where we have scaled AI enabling decision making, so the likes of lights out planning. And to get there, we have to go through each of the layers underneath. So from data to information to knowledge to wisdom. So I'll start from the bottom and sort of explain what each layer is and the strategy that we've been taking to each layer. So data in itself is meaningless. So 42 is data, but without any context, that could be 42 miles an hour, or it could be the meaning to life and everything. Apologies for bad reference there, but it's 42 in itself doesn't mean anything. So the first step is enriching that with metadata and providing some context around what that data means. And the strategy we've implemented at AstraZeneca is the data product strategy for productizing data sets and productizing data and providing that context and creating findable, accessible, interoperable, reusable data components. And that helps get us to the information layer. But information in itself, still doesn't give you what's needed to provide that enterprise context, and really understanding the relationships between your different data points is critical for capturing the context that you're working in. And this is where we've been focusing a lot on knowledge graph and the knowledge graph strategy and how we can leverage graphs and ontologies and semantics to help feed the scalable AI ambition. So I guess putting that into a sort of a timeline view and a view of the data foundation journey, this is what it looks like. And I guess one of the key things I wanted to call out here is that we're thinking of knowledge graphs as a foundational platform capability for scaling AI. So we're not looking at it from a specific use case perspective. It's more around how can you create the relevant ontologies to describe the processes that we're working with in operations, from supply chain to manufacturing to procurement to late stage drug development. How can you instantiate those and create knowledge graph products that are scalable and interoperable? And how can we capture the underlying knowledge that we have stored in our data, be that from unstructured documents like SOPs or from some of the systems data that we have coming through from manufacturing execution systems or our enterprise resource planning systems, and structure it in a way that it's easy to consume for AI to scale and create for aligned decision making across operations when we look at that agentic framework that will sit on top. So this journey has evolved over time, but it started by focusing on how can we get our data into one place, and initially thinking about systems data. So creating the data lake and data warehouse strategy. Then, as I mentioned before, the data products, there's a process of ensuring the right ownership of that data and converting it into information and making it easy for a federated mesh model to work, so different domains can own and manage and build their own data products, which can then be consumed by different domains. And from a platform capability, the key thing we were looking at there is how can we speed up the process of building data products while still enabling ensuring that we're findable or conforming to the FAIR principles. And then that's led us to Operations Knowledge Fabric, which is really around how can we capture the enterprise context within the data platforms to scale AI, which is what we will go into next in a bit more detail. So Maria, back over to you.
Yeah, thank you. So ultimately, to have AI-driven insights and being able to rely on AI agents or on more simpler LLMs for decision making, it's really a question of ensuring that we have a very solid data foundation that really enables to provide in a simple and compressed and useful way the context about the data alongside the data. And so this is where the challenge is, because ultimately we are developing platforms that need to be not only data platforms, as in the classic understanding of how they are, but that have to intrinsically integrate the concepts of ontologies and knowledge graphs as part of them. So traditionally, we understand data platforms as the data foundation and knowledge graphs as application centric. But here we really want to shift this paradigm and to ensure that we have this context that is part of our domain understanding and of our domain knowledge, and not only within applications. So the products that we are building on top of our data. And so with this, Russell, if you can please go to the next slide. So with this, we are in process of building the operations knowledge fabric, also called OKF. OKF is our knowledge platform. So that is a data platform that integrates also this kind of semantic layer and a knowledge layer. So it is a multi-layered, and it does follow the same knowledge pyramid that Russell have been describing in the previous slides, where we have a foundation of data. So here we have relational data, so structured data, unstructured data, IoT data, ARP data, that flows all together and that is being cleaned, contextualized with extra metadata, and put all together in a data lake. However, we cannot just throw randomly LLMs and chatbots on top of those on this data, because even the most accurate metadata doesn't really provide the exact context, and the context about the context about the data that is exposed to the LLMs. Therefore, we need to build what we call a semantic layer. A semantic layer is a collection of ontologies that describe our business. So, for instance, we will have ontologies that describe how our manufacturing processes work, how our supply chain work, how our drug development works. So, for example, in drug development, we will have different types of relationships between formulation types, materials that are used within those formulations, the drugs or the drug types that are being produced due with those formulations. And so we really create an ontology, so a map of things, how those things work in AstraZeneca. And this is what we would call the semantic layer, or a collection of domain ontologies. When we have data that needs to be contextualized with this domain ontologies, we then create a knowledge layer that would be created per use case, where we map the data together with those ontologies to really provide the context for the data. So this kind of semantic meaning context, where that was going to be also exposed to the agents, but also to the data scientists for them to do graph data science. And this is quite invaluable, because this is how we can make an LLM really understand that a batch process is a process, and that a batch order is something that comes after a batch process, because in the way that they're linked within an ontology. We can also expose in a better way and explain, quotation marks here, quite intrinsically to the agents and to the AI bots, how different batches relate to each other, when the batch is the same batch but it just moves along the production chains. And so to do this, we are doing what we call a semantic enrichment, where the data, the actual data points are mapped and contextualized with ontologies. practically speaking, we have the ontologies that sit in RDF. We have the data that sit in relational databases or in unstructured versions. And we are mapping those two together to put them in Neo4j. Neo4j has the great advantage that is extremely interactable, and we can do a lot of things with nodes, with edges. We can add a lot of information that is both semantic and information centric in nodes and on relationships. And so this is very handy for LLMs to really get not only the data and the values, but also get the context in the same way as our brains work when we see that a dryer, for example, on a factory floor. We will know this is a piece of equipment, so it should be acting in some way. In the same way, the LLM will have this information encoded in the nodes and in the relationships together with the data. So this is how we are building this operations knowledge fabric through enabling the semantic layer that is consistent across our domains, and building these bits of knowledge layer that are ultimately interoperable, are connected, and provide context and data to the LLMs and to the data scientists to finally unlock value and to generate insights that then allow to go and to act where it is needed for our colleagues. And so next slide, please. And with this, there are different parts of our operations knowledge fabric. It is comprised of course, the platforms. We have Neo4j, we have also our data lakes, and we have our semantic layer, and we have tools. So we're building in-house a tool called Ontology Assistant that helps to accelerate the development of the ontologies for our business, so both of the domain ontologies to really ensure that we have a very homogeneous and consistent semantic layer, but also to provide extra semantic support for the use cases. We also have accelerators that we are developing and that are part of the operations knowledge fabric. This consists of reusable graph models. And here we are talking both about application ontologies, but also Neo4j graph models, so Neo4j graph schemas. We are aiming for reuse as much as possible the way that we are mapping the data on the ontologies. So we are having reusable mapping rules and the mapping themselves. And of course, last but not the least, reusable code and engineering pipelines. So every time that we have a use case that is being up, we don't need to reinvent the wheel, and we are very quick into setting up the data infrastructure, setting up the data pipelining, setting up the Neo4j database, and to do this very quickly and in the most efficient way. Because at the end, what we need is to accelerate. We cannot afford anymore to build a data product or to build a knowledge graph in 6 months. We need to start doing this in 6 days. And of course, all of this is also governed with standards. We do have quite strict semantic and knowledge graph standards, processes, and governance. So here, of course, we are aiming really for FAIR in its complete understanding, because the data has to be findable and accessible. But using ontologies and using this kind of reusable and interoperable tools allows also for actual and heavy data interoperability. So it's something that maybe you have heard in other Neo4j presentations, but Neo4j does enable cross-querying between different Neo4j databases within a single query. So we are aiming for this. We're aiming for this level of data interoperability, where we are capable in a single Cypher query to query different databases and to have a consistent response. And of course, we are really aiming for reusability, because data is what we have. Data is our most precious asset, and we need to reuse it as much as possible to not redo the same experiments again. We also want to reuse the data to be able to generate more data and to do synthetic risk experiments, so to do virtual experiments. So here we were investing quite a lot in digital twins, where the data is used to mimic the experiments that never took place, or to mimic the factories also, because factories also can have twins, and how we can optimize the process flows within those factories. So overall, OKF is a constantly evolving set of platform tools, accelerators, standards, and governance, which is organized in a way that evolves along time and evolves along the data that we have with the technologies that become available to us, while being super strictly controlled, because quality for us is above everything. We need to be really consistent with our deliverables, and we need to be really consistent in tracking what is happening to our products, where they go, how they have been produced. So all of this enables to not only accelerate the insights and accelerate the productions, but keeping the quality of them. So if you go to the next slide, Russell, please. We are ready to demonstrate you some of the applications of the OKF, so of the Operations Knowledge Fabric. And over to you.
Awesome. I guess just before I jump into one of the applications, to build on what Maria's just said, I think Operations Knowledge Fabric has been a transformation, really, around how, transformation from how can you capture the enterprise knowledge within the data platform to almost create this enterprise brain to enable aligned decision-making or agentic decision-making going forward. So it's captured all of the elements that you would expect from a digital transformation in terms of the tools and technologies that have been implemented, the processes and governance procedures, and also the people capabilities that need to be developed. So yeah, just wanted that one last build, but to, I guess, complete the picture, we wanted to show an application on top of the platform, and talk through one of the key use cases that we have been working on and partnering on to show how this sort of works in action, and also talk a bit more about the supply chain applications. So yeah, the specific use case is called the digital supply chain map, and I guess life sciences supply chains are relatively complex. They tend to be very long in terms of the lead times for the different manufacturing steps and transportation steps. In total can be over 2 years end to end, which gives you not a lot of, well, it means you have to forecast quite a long way out, and consequently there tends to be a lot of inventory, so a lot of stock held in the supply chain based on the supply and demand variation and the need for high service level. So really complex supply chains, often spanning multiple countries. And one of the key challenges was initially it was how do we create a common view of what these supply chains look like? And this can be for master data setup, but also to help with understanding the impact of, say, a new tariff, if that ever caused challenges within, whoever got hit the sort of pharmaceutical supply chains. So to understand that, historically there've been a load of PowerPoint slides, but we've been on a process of helping digitize that process and derive these supply maps or supply chain maps from the underlying data. And given the interconnectedness of a supply chain, the knowledge graph or Neo4j has been used to build this out based off the principles we've described from the operations knowledge fabric. So yeah, I'll talk through just a view of what this supply chain looks like. It's been filtered just to one market to make it easier to see how this all fits together. So talking about Tagrisso here, which is a tablet, and then the multiple stages of manufacturing. And then it's filtered just on the French market. So the first step is around the raw materials, and multiple different raw materials here. The different colors relate to whether they're internal or externally manufactured. So these yellow ones are externally manufactured products. Multiple different raw materials that then get fed into creating the intermediate manufacturing, which is done in Switzerland. From these intermediates, you then create the API, the active pharmaceutical ingredient. And again, there's a transportation between Switzerland and Sweden in this case. The API then gets formulated into the tablet before being packed and sent to the French market. So this is just one example for one brand. I think there are 96 different brands, and then all of the different markets, so hundreds of different markets that we need these maps to visualize initially. I guess I called out some of the challenges around inventory and lead times. So what we're doing is this is becoming the foundation. And then more and more information is getting built into these maps to help supply chain professionals identify where some of the key bottlenecks are, what the challenges are. And that sort of feeds into the next view that we're going to, or in terms of where this is going. So to start with, we're concentrating on what information do we need to visualize to help people make decisions. The next step is to start inferring or help explaining some of the phenomena that we're seeing within the supply chain. So understanding the cycle times or the capacity, or looking at the cause and effect between, say, the OTIF level, which stands for on time in full, or the service level from customers, and what were the causal drivers of poor service. And then ultimately leading into recommendations. So once you understand what could have caused an inventory shortage or a stock out, what are the actions that we could take, and how can you simulate those actions through this complex network where one decision might impact another. So for example, changing a stock policy might mean that you start seeing more the need to transport by air more often. So everything is so interconnected. Understanding the impact of one decision on another is critical. In terms of then, the last step would be looking at how we can prevent issues from reoccurring and continually improve the supply chain processes. So just wanted to call this out as an example. The knowledge graph that sits underneath this is going to become a foundational knowledge layer for not just this application, but multiple different applications going forward, and create that single view of how the supply chain is connected. Some of the use cases Alex mentioned earlier will also be applicable, from network optimization, parameter optimization in terms of how do you plan ensuring flow through the supply chain. Multiple different use cases, but the knowledge graph being the foundation, and then that will enable the AI ambition for a self-healing supply chain going forward. With that, I think we've come to the end of our planned presentation, but happy to take any questions.
Thank you very much, Russell.